Alrighty. Okay, so on numbers 5 through 8, like I was saying, these guys aren't going to be as nice. Maybe there's not a nice power of 3 that will give us 10. In fact, there's not. Okay, so we want to figure out a way that'll work for all of these guys, and that is our change of base rule that we learned last time. So let's go ahead and remind ourselves what the change of base rule is. Okay, well, the change of base rule means we're going to have log. We'll say that the base is A and the bigger number is B, right? Okay, well, in order to evaluate this, you're going to take log of your bigger number in your calculator, divide it by log of your base. Right now we're just using A and B. I think last time we used X and Y. Doesn't matter. Okay, so number 5, well, my base, my little guy is A in this case. My bigger number would be B. Okay, so what am I going to punch into my calculator?
Log 10 divided by log 3.
Love it. Log of my bigger number divided by log of my base. Okay, well, let's just take our calculators, clear them out. We have our log button right here. Okay, push it. Log of 10, close parentheses. Make sure you close up these parentheses before you click divided by log of 3, close parentheses. And it gives us our answer. Let's round it to 2 decimal places this time. So if I'm rounding it to the 2nd decimal place, we look at the 3rd guy. Is this 5 going to bump the 9 up or keep it a 9?
Bump it up.
Bump it up. So this would actually be 2.10 or 2.10. We definitely like the calculator better than guess and check. I do. Okay, let's try it again. So we have log 6 of 38. Okay, so what are we going to punch into our calculator? Which one goes on top, 38 or the 6? Which one goes on top when we're dividing? 38, good job. That means my base 6 goes on bottom. Okay, so let's go ahead and punch this into our calculator. Log of 38, close parentheses, divided by log of 6. And what is this going to round to? Is my 0 going to bump the 3 up or keep it a 3?
2.03.
2.03. Beautiful. And there we go. Try, just try 7 on your own. We'll skip number 8. Try 7 on your own. It's exactly like our starters. Go ahead and punch these in, just for more practice. Okay, I'll freeze and then we'll compare answers. So punch it into your calculator, see what you're gonna get. All right, let's see what you got in 5, 4, 3, 2, and 1. Give me a thumbs up. You got the right decimal. Punched it into my calculator right. Awesome job. Love it. Okay, let's go ahead and skip number 8. How are we feeling with converting logs, or evaluating logs, excuse me. Fist of 5. Show me a fist of 5. Oh yeah, I can punch it in the calculator. Could use a little more practice. Have no idea what you're talking about. I don't believe you, Isaac. I don't believe you.
I'm serious. I don't know what the hell you're talking about.
Then I will help you later. Okay. Let's review. For numbers 9 and 10, I think just 9 and 10. Yep. 9 and 10. Do you guys see log anywhere in those equations?
No.
No. What we're doing is we're actually graphing the exponentials. Okay, so these guys, think of them as like the originals. The OGs, the exponentials. This is kind of where we get logs from, right? They're inverses of each other. What always works when we're graphing something? You guys remember? Starts with a T. A table. The table. Beautiful. So we're going to give ourselves a table. One column is my X, one column is my Y. So in my X's, if you remember, I like to give myself some negatives, a 0, and some positives. Okay, so what we're actually doing here is we're choosing values to plug into X, solving it, seeing what we get for Y. Okay, so let's start with the positives. Let's plug positive 2 in for my 4 to the X power. What is 4 squared gonna give me? 4 times 4.
16.
16. That means when I plugged in a 2, I got out 16. What about 4 to the first power? That's just 4. So when I plugged in 1, I got 4. This guy's easy. What is anything to the 0 power?
0.
1.
It's 1. When I plugged in a 0, I got 1. Anything to the 0 power is 1. Okay, what happens when we have a negative exponent, you guys? It flips it.
Around.
Yeah, it flips it over, right? So instead of positive 1 being 4 over 1, for negative 1, it is
1 over 4.
1 over 4. And instead of positive 2 being 16 over 1, negative 2 is 1 over 16. Got it. Okay, so these became our coordinate points. So let's go ahead and put them on our graph now. Okay, so I have negative 2 for my X, that's right here. And then it wants me to go up 1/16. That's like barely up at all. Negative 2 up 1/16. Okay, adjust that a little bit. Then it wants me to go to negative 1, right there on my X, and go up 1/4. Again, that's like barely up. A little bit higher than the last one. Okay, then I have 0 right here, up to 1. 1 up to 4. And 2 all the way up to 16. So we see with exponentials, they get really big, really fast. Okay, we remember that. Not too bad. Let's try that again. Graphing another exponential. Okay, we know a table always works when graphing anything, so give yourself a table. Give yourself your negative values, your 0, and your positive values. I like starting with the positives. Those are easier. Okay, so now I'm plugging it into 3 to the X power. So what if I were to plug in 2? What is 3 squared, or 3 times 3? What would I get? 3 squared. Thank you. We would get 9. Plug in a 2 for my X, I'd get 9. What about 3 to the first power? Do not overthink this one. What is 3 to the first power? It's just
3.
3. What is anything to the 0 power? 1. And then these negative guys, just flip these guys over. So for -1, instead of 3 over 1, it becomes
1 over 3.
1 over 3. For -2, instead of 9 over 1, it becomes
1 over 9.
1 over 9. You guys are good. Okay, we put parentheses around them because that's how coordinate points are written, right? Parentheses x comma y. Okay, let's go ahead and put these on our graph. So find -2 up 1/9. Again, just barely up. -1 up 1/3, a little higher, but not much. 0 up to 1. 1 up to 3. And 2 up to 9. So it doesn't get as high as fast as 4 to the x power, but still it shoots right up. Okay, show me a fist of 5 on graphing exponentials. Giving yourself a table, plugging in your values. Nice, I like it. 4s and 5s, that's awesome. Okay, let's turn your paper over. What in the world? Now what are we graphing? Are we graphing exponentials anymore?
Log.
We're graphing logarithms, okay? But keep those exponential graphs in your minds. Remember, they're just inverses of each other. They're going to be related somehow. They're opposites, okay? Before we get to these guys, let's go ahead and take this empty space on our paper right here and give ourselves what we call parent functions. Okay, we call them the parent functions in math. Think of them as like the OGs. Nothing's been added yet. They are the parent functions. Okay, so let's see, what bases do we have? Let's go y equals. This is our first parent function that we're going to talk about. Okay, so here's the thing. When graphing a logarithm, it would be really hard to plug something in for x and figure out what y would be. So what we need to do is convert it to an exponential. Make it look like the guys we were just graphing. Okay, so how we convert that? Remember, we keep our base. Our base is 2. But then we go in this little circle here. We pick up the y. So 2 to the y power. And it equals x. Two to the y equals x. This is going to help us graph this guy. Okay, so now looking at this guy, which one do you think it would be easier to pick values to plug into? X or y? Which should we plug values in for? X or y?
Y.
Y. Beautiful. Okay, look back on the other side of your paper, right? We were picking values to plug into the exponential spot. Last time it was x. We're going to do the same thing, except this time it's y. Nothing too different. Okay, so give yourself a table. Still x and y, but this time we're choosing values for y. Okay, and just for time's sake, let's just do -1, 0, and 1. Okay. Alrighty, so if I were to plug in 1, let's start with the easy guy. 1, what would I get? 2 to the first power. Don't overthink it. What is 2 to the first power?
2.
2. Okay, we get 2. Let me do a different color. What is anything to the 0 power again?
1.
1. Okay, the negative flipped it over, so instead of 2 over 1, it becomes 1 over 2. Oh, this looks familiar. This is like what we were just doing, but it's been flipped to the other side, right? Oh, wait, didn't we just talk about that with inverses? Yes, you guys are so smart. Okay, so these are what we call our parent function points, and these are really going to help us when graphing this guy. Okay, now I'll be super honest. We're taking it like levels 0 through 5 right now. So if you're like, what is going on? That's totally fine. Have these parent function points written on your paper and you'll be okay. Okay, let's look at now number 14. Okay, ignore 11, 12, and 13. Let's just look at 14. We have our log base 2, but what's been added, you guys? What do we see now? Parentheses, something inside the parentheses, something on the outside of the parentheses. Okay, so these are what we call, these little added things right here, transformations. And I'm going to run out of room. Transformations. Something's been added to your parent function. And guess what? It is as simple as you have your parent function. These transformations are just making it move on the graph. That's it. Just making it move. Okay? So, let's look at inside our parentheses. Whenever you have something inside the parentheses, you're going to move left or right. You're going to take those parent function points that we just talked about and you're going to move them to the left or right, depending on what the number is. On the outside, plus or minus on the outside of the parentheses, that's going to tell you to go up or down. Okay, this is like, whoa, this is legit like secondary math 3 big stuff. Okay, inside the parentheses moves you left and right. Outside moves you up and down. So let's see how these moved. First of all, let's put our parent function points on our graph, but don't connect them yet. Okay, so here's what I mean. My parent function points were 1/2, so find 1/2, then go down to -1, that's right there. Then I have 1, 0, right there. And I have 2, 1. You know what? I do want to connect them. Okay, so this is what a logarithm graph looks like. It's just a flipped over or reflected exponential. You see how it's kind of the opposite of what we were just graphing? Mm-hmm. Still the basic shape, just kind of reflected the other way. Okay, so let's figure out how it wants us to move these points. Okay, so inside my parentheses, whenever you see a negative, okay, so we have x minus 1 in our parentheses, quickly. Negative means we're going to the right. This wants us to move it right 1. What if it had been +1? Would we go to the right? We'd go to the left one. Good job. Okay, so minus is right 1. Okay, then the -1 on the end, right? That guy right there. He wants us to move down 1. What if it was +1 on the end? We would go up 1. Man, you guys are good. You guys are good. This is like hard stuff, and you guys are picking it up. I'm so proud. Okay, so let's take our parent function, our guy that hasn't been added, and let's move him to the right 1 and down 1. Okay, so pick up your first point. This guy right here wants you to move to the right 1. Okay, You're still in between. You're still at the half mark. Right one, down one. Boop. He moved. The right one, down one. Not too hard, he just moved. Okay, pick up your next point, right here. Again, he moves to the right one and down one. And pick up your last point. To the right one and down one. Oh, and look at that. He's been transformed. He's literally just been moved. Whoa. That's like legit level 10 stuff right there. Okay.